Good afternoon, my dear subscribers. In this video, I am going to run a simple logistic regression model. I'll estimate it and I'll interpret its results. So I welcome you to this new video. Here is my presentation scheme. As I mentioned, I'll run simple logistic regression model with one scale variable, and then I will run the same model with the one scale variable and its square. That is, my scale variable is age, so I will use age and age square in the regression model. After that, I'll estimate the predicted probabilities of my dependent variable diabetes at various age group, and then I'll plot the predicted probabilities against the age groups. And finally, I'll show you how to send the commands in Stata to do file, so that you could keep it for future. So again, I'm using this file, and this time my model is not a linear regression model, but it is a binary logistic model in which the dependent variable is a categorical variable. It is equal to 1 if an individual is diabetic and 0 otherwise. My only scale variable is age, that is independent variable, and its quantitative or continuous numeric or scale variable. It is also known as regressor or explanatory variable. I am going to run logistic regression of a binary categorical variable diabetes on age, and this is my sample size. 10,351 individuals have participated in this National Health and Nutrition Examination Survey. In order to do that, I'll open my Stata file, which contains this data. So here is my file that I have already opened. First of all, I would like to summarize the two variables that I'll be using in this analysis. So I will write sum. One of my variable is diabetes and another one is age, and this is the summary. 10,349 observation for the diabetes, and for age these are 10,351. These are the mean values, and these are the standard deviations. These are the minimum and maximum. Since the dependent variable diabetes is a categorical, 1 for those who have diabetes and 0 for those who don't have diabetes, and this is the descriptive statistics of age variable. So first of all, I will run logistic regression. So I'll go to state, and this is binary, and I'll go to binary logistic. My dependent variable is diabetes, so I look for diabetes. Here is diabetes, and my first of all I will delete this, and now I will use this as my independent variable. So I will submit, and here is my result. This is the odd ratio for age. This is its intercept of this model, and as I mentioned, 2 of the categories were missing for diabetes, so Stata has taken 10,349 observations for this model. This is the p-value of the chi-square state, and this is the pseudo r-square, and these are the standard errors, z values, and probability of z values, and 95% confidence interval. Now next I regress the same model, and I will write logistic and diabetes, diabetes, age, and c age, hashtag c age. Now this means the main effect of age, and this means the effect of the square of age, and here is my results. These are my results. Now total observation again 10,349, and this is likelihood ratio chi-square. Its value is 348. This is probability value of the chi-square, and this is the pseudo R-square. Now this is the coefficient for age, and now the coefficient of age is different as compared to this one, and the constant has also changed. We can compare this value with this value, but now I have the square of age, and its odd ratio is 0.99. When the odd ratio is greater than 1, it means that there is a positive relationship between age and the probability of having diabetes. When the odd ratio is less than 1, then there is a negative relation, and when there is positive relation, the z value will be positive. When there is negative relation, the z value will be negative. That is why here we have minus 2.48. Similarly, this is less than 1, so its z value is that is negative 10.64. These are their 95% confidence intervals. Now let me test assumption of age and C age and C age. Now I test that jointly the coefficient for age and the coefficient for age square is equal to 0. So this is the hypothesis, testing hypothesis, that the coefficient of the age, that the coefficient of the main coefficient, the coefficient of the age for main effect is equal to 0, and then the coefficient for the age square is equal to 0. And I am jointly testing this with this chi-square test. Its p value is 0.0000, so it's less than 0.05. So we reject the null hypothesis, and we conclude that the coefficient of age is significantly different from 0, and the coefficient of the age square is significantly different from age different from 0. After this, I will do something funny, and that is I'm going to estimate the predicted probabilities, and I can do that with the help of post estimation. That is, after estimation the regression model, I'll go to post estimation, and I'll click on the marginal analysis, and after that I'll click on this, and I will launch this. If I launch this, my covariate is this, and whatever covariate is, I will write it here. Since I have already used age as my covariate, which is a continuous variable, and here I can tell the Stata that what should be the interval of age. So I will start with the 20 within parenthesis 10 and 80. So this means that give me the prediction of probabilities for the age group for 20 at the interval of 10, that is 20, 30, 40, 50, 60, 70 and 80. After this I'll submit, and here are my probabilities, and the command is margins comma at age equals 20 parenthesis 10 and then 80. So this means that I have asked Stata to give me expression 1 at age equal 20, expression 2 at age equal to 30, and so on up to 7, that is, and 7 means that the age group is equal to 80. And after giving this, Stata has given me these predicted probabilities at various age groups. So this means that the predicted probability for diabetes at age 20 is equal to this, and the predicted probability for diabetes, for having diabetes at the age of 30 is this, and as age increases, the predicted probabilities increases. So this is how we can predict margins or marginal probabilities, predicted probabilities for the different groups of the continuous independent variables. So I have given these various intervals of age. After this, I'll plot these. So I'll go to post estimator again, and this time I'll click on profile plots after marginal analysis, and I will launch this. And after launching this, I will give the various intervals age groups of age on the x-axis, and after this I'll press OK, and here is my adjusted prediction with 95% confidence interval. So you see, the probability of having diabetes at age 20 is this. When age increases from 20 to 30, the predicted probability also increases, and similarly, as age increases, the predicted probabilities of age also increases, and you can see that the predicted probability of having diabetes at age 80 is higher as compared to predicted probabilities of having diabetes at age 70, and so on. So this is very interesting results, and I can also show you an additional command with the my analysis, and it's here. Now I have used so many commands here, so I can select all of them, and after that I'll click on this command, send selected to do file, and it will create a do file which is here. It has created do file, that is logistic diabetes on age, and then diabetes regressed on age and age square, and then this test of parameters of both age and age square. This is the marginal analysis, and this is the marginal plot. So it also gives me, and I can save this by giving save as, give it any name so that you can use this file for running the logistic regression analysis later on. So my dear subscribers, this is a very simple analysis of logistic regression model having one independent continuous variable. In the next video I will also use some independent categorical variables along with age. So thank you for watching this video. Kindly subscribe to the video and this channel, and do not click on the bell icon so that you could continuously get notification about the videos that I'll upload for you. Kindly share this channel with your colleagues, friends and students in various WhatsApp groups so that it could reach to the maximum possible number of people. Thank you.